Hello everyone. Today we're gonna solve a problem on Master in Physics. The problem says write the electric field at point P in component form. Okay, let's get started. Okay, I already have the paper here. First, let's put a number on every charge. Let's name this as 1, 2, this 3. We're gonna start. Electric field 1 is already on the X component. So let's just name this X. Is equals to K, the charge, which is negative Q, divided by the distance between 1 and P is gonna be L. It's gonna be L, all this is gonna be square. Now, let's do the second, wait. We're gonna jump to the third, because it's gonna be easier to do. E3, well, charge 3 is already pointing on the Y component, so this is gonna be Y. This equals to K, the charge in negative Q, and the distance is gonna be from 3, charge 3 to P, it's gonna be L, so it's gonna be L square. Hello, I just wanted to let you know that E3Y and E1X are gonna be negative, not because of the charge, but because of our coordinate system. E3Y is gonna be pointing down on a coordinate system, so it's gonna be negative J hat. And E1X is gonna be pointing to the negative I hat. So that's the reason our values are gonna be negative, not because of the charge. And also, well, we're gonna need, over here we're gonna get an angle, so we're gonna have an cosine for the X component and a sine for the Y component. And for the electric field of charge 2, we're gonna have two components, because they're gonna be diagonal, so we're gonna have a X component and a Y component. We're gonna find this distance first. Let's name this R. R is gonna be equals to the square root of this distance and this distance. So it's gonna be L squared plus L squared. The angle, we're gonna have an angle over here, theta. Angle theta is gonna be equals to, well, we know it is a rectangle because you have length L and height L as well. So this angle over here is gonna be half this total angle, which is 90 degrees. So angle theta is gonna be 45 degrees. So component 2 is gonna be an X component, and this X component is gonna be looking to the right, gonna follow the cosine. So we're gonna write this as K charge, it's gonna be 4K divided by the distance. The distance is gonna be R, so this is gonna be square root of L squared plus L squared, and all this square. Over here we're gonna multiply with a cosine of 45 degrees. And we can do the same for the Y component. E2Y is gonna be K for Q. We can already cancel out the square root with the square over here. So we're just gonna write here L square. And we're gonna multiply it. Because we're doing the y component, we're gonna do the sine. 45 degrees. We can change the cosine of 45 degrees by square root of 2 over 2. And the sine is going to be the same. Square root of 2 over 2. Okay. Now we're going to combine the x component and the y components. For example, over here we have an x, and over here we have an x component. So we're going to do the electric field on the x component is going to be equals to E1x plus E2x. And this is going to be equal to k negative q divided by L squared plus over here we're going to have k for q, and we're going to cancel out the square root with the square over here, so it's going to be L squared plus L squared square root of 2 divided by 2. Okay. Now we can combine this 2, so we're gonna have 2L squared. This 2 multiplied by this 2 is gonna be 4. 4 divided by 4 is gonna be 1, so we can cancel out the 2's and the 4. So we can write down Ex equals, we can factorize, we can multiply the k by the negative q, so it's gonna be negative k q divided by L squared plus, well, we're gonna have square root of 2 k q L squared. And this, we can factorize the k, both sides, the q, and the L. So we're gonna have k q L squared. We're gonna have negative 1 and the square root of 2. So it's gonna be square root of 2 minus 1. All of this is gonna be on the component, so that means on the I component. I unit vector. For the y component, we're gonna do the same thing. Y is gonna be equals to this component over here and this component over here. So it's gonna be equals to E3y plus E2y. And this is gonna be equals to k negative q divided by L squared plus all these over here. It's gonna be k for q divided by, we can combine these two plus 2L squared plus the square root of 2 over 2. All this because of the sign. Okay, so we're gonna do the same thing. Cancel out the 4. These 2 multiplied by these 2 is gonna be 4. 4 divided by 4, it's gonna be 1. So I'm gonna write it down up here. Y is gonna be equals to, we're gonna multiply the k with the negative q, so it's gonna be negative k q divided by L squared plus square root of 2 k q L squared. We can factorize the k, q, and L squared as well. So this is gonna be equals to k q l square multiplied by square root of 2 minus 1. And this is on the j component. Thank you. And let me just write down the master in physics to see if it works. Okay. Okay, so we had all this I component, this for the j component. Okay, let me put it here. Maybe k q l square multiplied by square root of 2 minus 1 be on the vector side constants. Good. So okay. I plus we're gonna have the same thing, so it's gonna be k q l square multiply square root of 2 minus 1 and the j component. And let's see if it works. Alright, I'm gonna log in again. Just give me 1 second. Okay. Let me write it down again. K q l square, and this is gonna be multiplied square root of 2 minus 1 and the I component plus k q divided by l square multiplied by square root of 2 j component. And it works. So what we have over here is the answer. Thank you.